Right now, you could open an app on your phone and get walking directions to a city 3,000 miles away. You'd know exactly how far, exactly which roads, exactly how many days it would take. Ancient humans had none of that. No maps, no compasses, no written records of who had gone before them or what they'd found. And yet somehow, they walked out of one small corner of Africa and ended up on nearly every continent on Earth. They crossed deserts, they crossed ice, they sailed across open oceans so vast that some of those crossings still make modern sailors nervous. So the question is simple, but the answer is anything but. How did they actually do it? Nobody set out to conquer the planet. Ancient humans, especially hunter-gatherers, weren't migrating for the thrill of discovery. They were following food. Herds moved, so people moved with them. Plants ran out of season, so people moved toward the next place those plants would be growing. A group might only shift a modest distance within a single lifetime, but stretch that modest shift across hundreds of generations, and the numbers become staggering. This matters because it changes the whole picture. Nobody walked from Africa to Australia in one lifetime driven by pure willpower. It happened as a slow, multi-generational ripple, a population nudging its boundary outward generation after generation, chasing better hunting grounds, more reliable water, or simply more room as their own numbers grew. The human body is genuinely built for this kind of travel. Our efficient sweating system, our upright walking stride, our unusual capacity for sustained, moderate effort over long stretches of time, all of it adds up to a body engineered for distance. Studies of modern hunter-gatherer and traditional walking societies have found that covering 10 to 20 miles a day, on foot, carrying supplies, wasn't treated as some heroic feat. It was just Tuesday. A normal, sustainable pace for people whose bodies had been conditioned for it since childhood. But a strong body alone doesn't stop you from starving in unfamiliar territory. What kept ancient travelers alive was knowledge, an enormous accumulated understanding of the land itself, reading which plants signal water nearby, watching animal behavior to guess where a river might be, recognizing the specific weather patterns of a specific region before a storm hit. This wasn't something one traveler figured out alone on a single trip. It was generations of quiet observation, passed down by word of mouth, giving ancient travelers a level of confidence in unfamiliar terrain that a modern person, dropped into the same landscape with zero preparation, would struggle to match.
One of the most significant journeys in our species' history didn't require a boat at all, at least not much of one. Genetic and archaeological evidence points to early Homo sapiens leaving Africa through specific corridors, including a crossing at the Bab el-Mandeb Strait, linking the Horn of Africa to the Arabian Peninsula. During certain Ice Age periods, falling sea levels made that strait considerably narrower than it is today. This is a theme that runs through the entire story. Ancient migration wasn't only about grit, it was also about timing, taking advantage of the planet's own shifting geography. Nowhere is that timing more dramatic than the Bering Land Bridge. During the last glacial period, so much of the planet's water was locked into ice sheets that global sea levels dropped enough to expose a wide stretch of land connecting Siberia to Alaska, a region researchers call Beringia. Ancient humans didn't sail to the Americas. They walked there simply by following game animals eastward across land that is now hundreds of feet underwater. It sounds almost too simple, but that single geographic accident explains how an entire hemisphere ended up populated without a single boat. Not every migration had a convenient land bridge. The Polynesian expansion across the Pacific is a completely different story, one that required real, deliberate maritime engineering. Voyagers used double-hulled outrigger canoes large enough to carry entire founding populations, along with the plants and animals needed to start a new life on arrival. This wasn't drifting. Archaeologists have found clear evidence of intentional colonization, people who expected to find land and packed accordingly. And the navigation behind those voyages deserves its own kind of awe. Polynesian navigators read star patterns, ocean swells, cloud formations, and even the flight paths of specific seabird species known to nest on particular islands, all combined into a mental navigation system taught through years of direct apprenticeship, no charts required. Some navigators could reportedly sense an island they hadn't seen yet just from the way it disrupted the pattern of ocean swells around it. Modern researchers, with all our instruments, still find that kind of sensitivity hard to fully replicate. Polynesian canoes were just one branch of a much bigger tree. Different cultures, facing different water, built entirely different boats. Reed boats in parts of the ancient Mediterranean in South America, dugout canoes carved from single trees, used by river and coastal cultures worldwide, skin-covered frame boats in Arctic regions, where wood was scarce but animal hide wasn't. None of this spread from one central invention. It was solved independently, over and over, by different people staring at different water.
And then there's Australia, maybe the single most mysterious water crossing in ancient human history. Even at the lowest sea levels of the last ice age, the stretch of ocean between Southeast Asia and Australia never fully closed into walkable land. And yet the evidence says humans reached Australia at least 65,000 years ago, using some kind of deliberate watercraft, long before the more famous Polynesian voyages we just covered. We still don't fully know what those boats looked like or exactly how sophisticated the navigation was, but the fact itself is undeniable. Humans were experimenting with deliberate ocean crossings tens of thousands of years earlier than most popular history gives them credit for. Walking has a ceiling. There's only so much a single person can carry. Domesticated pack animals, horses, camels, donkeys, and in parts of South America, llamas, changed that math completely, letting groups move more supplies, more goods, and more people across greater distances. Camels in particular deserve credit here. Their ability to go long stretches without water, combined with a genuine tolerance for extreme heat, made them essential for crossing the Sahara, the Arabian Peninsula, and much of Central Asia. Once effective saddle technology let riders and cargo travel securely, camels didn't just help people survive the desert, they turned it into a highway. Not all long-distance movement was migration. A huge amount of it was trade. Goods and materials passed hand-to-hand between communities that never met each other directly, connected only through a chain of intermediaries. Archaeologists regularly find specific types of stone, shell, or other raw materials hundreds or even thousands of miles from where they originated. It's proof that ancient communities were far more connected, far earlier than we tend to assume. None of this worked without cooperation. A multi-week journey into unfamiliar territory took real planning, shared resources, coordinated decisions, trust between people who needed each other to survive the trip. Ancient long-distance travel wasn't a story of one tough individual, it was a story of groups. And it's worth being honest, it was dangerous. Starvation, dehydration, unfamiliar diseases, conflict with people already living on the land, and simple miscalculation all took their toll. The fact that our species now lives on nearly every continent doesn't mean every migration succeeded. It means the failed ones just didn't leave descendants behind to tell the story.
Rivers acted as natural highways, offering easier terrain than the forests or mountains around them. And once boats existed, they let people move goods with far less effort than walking. In the Arctic, sled technology paired with domesticated dogs made travel possible across conditions that would kill an unprepared traveler outright. And across deserts, treated animal skins, shaped gourds, and eventually ceramic vessels were engineered specifically to slow water loss through evaporation, sometimes the single difference between a journey that succeeded and one that didn't. Modern genetics has added a layer of precision archaeology alone couldn't offer. By tracing genetic markers across populations worldwide, researchers have confirmed and sharpened migration timelines that used to be rough estimates at best, one more discipline converging on the same story from a completely different angle. So how did ancient humans travel so far? Not through one brilliant invention, not through one heroic journey. It happened through slow, patient repetition. One generation walking a little further than the last. One navigator noticing one more thing about the swells. One traveler remembering exactly where the water was. There was no map guiding any of it. The map was being drawn, one footstep and one wave at a time, by people who had no way of knowing they were writing the story of how our entire species came to cover the Earth.